I'm pleased to welcome you to this webinar on vaccines, herd immunity, and how we get there. And our guest today is Dr. William Moss. William is a professor in the departments of epidemiology, international health, and molecular microbiology and immunology at the Johns Hopkins Bloomberg School of Public Health. He's also executive director of the International Vaccine Access Center and a deputy director at the Johns Hopkins Malaria Research Institute. He's a pediatrician with subspecialty training in infectious diseases, and he has worked around the world, specifically in Ethiopia, Kenya, South Africa, Zambia, Zimbabwe, and India. And his broad research interests are the epidemiology and control of childhood infections in resource-poor countries. He's appeared regularly on CNN and C-SPAN and regularly answers questions on the International Vaccine Access Center's website and various media connected to it. I particularly recommend scanning their Twitter feed on their website for some really excellent short question and answer sessions that are on there. And of particular interest to singers and NATS members is that William is the brother of our colleague Heidi Moss, who teaches in the San Francisco Bay Area. Thank you so much for joining us today, William.
Alan, thank you very much for having me, and it's a pleasure to be here.
Your work around the world through the Vaccine Access Center seems particularly relevant to the challenges the world, but particularly those of us in North America face with production and distribution of COVID-19 vaccines. Provide us some context on how the knowledge the center has gained through its past efforts has been applied to this particular crisis.
Yeah, so there's a lot of work has been done, and I should say, Alan, I think it's remarkable that we're actually in this position where we're 1 year into the pandemic discussing vaccines and their distribution. It's been truly a remarkable achievement. One of the things that IVAC has focused on is really improving access for vaccines around the world. Once they're developed, vaccines often, it can take a long time for them to be actually used around the world. And so our work at IVAC has really been to accelerate the access to vaccines globally. Here we're in a situation where the vaccine development has been, really remarkable. 1 year into the pandemic, we're talking about, vaccines that have 95% protective efficacy in these large, what we call phase 3 trials. We are already seeing, vaccines being used around the world, but we're also facing a lot of challenges, and we'll continue to have challenges. There are still things we need to learn about these vaccines, and I look forward to discussing these with you. Oh, you're on mute, Alan, I think. Sorry.
As of today, where are we with vaccines? I think is a question for us. The types that are out there, those that are coming. Should we be concerned about trying to receive a certain type of vaccine?
Yeah, so we have two different vaccines, although we'll talk about the similarities, that have received emergency use authorization here in the United States, and those are the two vaccines, the Pfizer vaccine and the Moderna vaccine, that are being deployed right now in the United States. These vaccines use a novel vaccine delivery platform, although there's been work on messenger RNA vaccine delivery for over a decade. So one thing for people to understand is that even though these are new novel vaccine platforms, mRNA platforms for delivering vaccines, there's been a lot of work, a lot of science that underlies these. So we were kind of ready for these vaccines to be developed. So the way these two vaccines work, and maybe I'll just talk a little bit about how these COVID-19 vaccines work, because they ultimately all have kind of the same biological or immunological basis, just different ways of getting there. And then we can talk about kind of different other vaccines that are kind of in the pipeline. So the way SARS coronavirus 2 is obviously a new virus that was first identified in China in December of 2019. The way this virus enters our cells, and all of you will know or recall that viruses need to replicate within cells. So this virus needs to get into a cell, and it has on its surface something called the spike protein, and many of you have heard of that. In fact, coronaviruses get their name from crown, and because of this spike protein that's very prominent if you look at this virus with electron microscopy. So this spike protein on the surface of these viruses is what binds to what we call the receptor on our cells, and that's how it enters our cells, and then the virus replicates within our cells, and it ultimately releases many new virions. So all COVID-19 vaccines really work by stimulating our immune system or preparing our immune system to identify and respond to the spike protein. And the primary means by which these vaccines protect us from SARS coronavirus 2 is by producing antibodies that bind to that spike protein, block that spike protein, and basically prevent the virus from entering our cells. So the question then is, how do we best prepare our immune system to recognize that spike protein when we're faced or when we're exposed to SARS coronavirus 2? And so the different vaccine platforms use different mechanisms of basically preparing our immune system. Maybe what I'll do is start kind of backwards and kind of explain different ways of doing this. So a very traditional, long time way of making vaccines against particular viruses is to basically take the virus, the whole virus, and inactivate it so that it can no longer replicate, but it still kind of maintains its structure. So this was used, for example, with the inactivated polio vaccine that was developed by Jonas Salk back in the mid 1950s. And there are a number of examples of inactivated viral vaccines that we use today. So that's one strategy of producing a SARS coronavirus 2 vaccine, and there are a number of inactivated SARS coronavirus 2 vaccines that are in development, even in use, particularly a number of Chinese companies. Not here in the United States, but that's one basic way of making a vaccine. Another basic way is just to take the spike protein and synthesize that in various other types of cells, and basically inject the spike protein itself and have that induce an immune response. Often those types of protein-based vaccines use something we call an adjuvant, or that basically helps stimulate our immune system. And we have a number of kind of protein-based vaccines. So for example, vaccines against tetanus or against diphtheria that we've all had. Those are protein-based vaccines. And so there are a number of protein-based vaccines in development. One of the ones that's furthest along in the United States is called Novavax vaccine, where they take that protein and kind of make very small particles called nanoparticles. That's in study right now, and that may be one of the vaccines that we see in the coming months, these protein-based vaccines. Another strategy for stimulating our immune system or preparing our immune system is, instead of injecting the protein or the virus, as I just described, which are older types of vaccine strategies, Instead, we basically provide the genetic recipe for our cells to make the protein, and then our immune system responds to that. So that's what's kind of quite different here with some of the more advanced vaccines for COVID-19. So, for example, the adenovirus vectored vaccine. So this would be like the AstraZeneca University of Oxford vaccine, or the Johnson and Johnson or Janssen vaccine that people may have heard about. These are in advanced clinical trials, and again, we may see an emergency use authorization for such a vaccine, either the J&J or the AstraZeneca in the United States in the coming months. What these do is use an adenovirus, which is obviously another virus. There are many different types of adenoviruses. They can cause a common cold, but these viruses are used as what we call a vector, and they're made so that they can't actually replicate within our cells, but they're used as a packaging system to get the genetic code into our cells, and then our own muscle cells will produce the spike protein, release that out of the cells, and our immune system will see the spike protein and then be ready to respond with a very vigorous immune response should we be exposed to SARS coronavirus 2. And then lastly, the messenger RNA. So that kind of that's in some ways the simplest type of vaccine delivery platform, although it took a lot of basic science research to develop these. Here, and this is the Pfizer and the Moderna vaccines that are being used here in the United States. What they do is take the messenger RNA, which is basically the genetic recipe for the spike protein, that's injected into our cells. Our cells make the spike protein again. Our immune system sees that, is kind of primed, and then if we're subsequently exposed to the SARS coronavirus 2, our immune system is ready to fight it, and that virus cannot replicate. So that's kind of a short overview of various vaccine platforms, kind of leading up to the messenger RNA type of vaccine, which we're using now in the United States under these emergency use authorizations.
And should we be concerned about trying to receive a certain type of vaccine?
Yeah, so that's an important question. I can tell you both the Pfizer and the Moderna vaccine are very similar, both in terms of their safety profile and in terms of their protective efficacy, remarkably similar. And the way we know this is from what we call phase 3 clinical trials. So these are large studies in which tens of thousands of individuals have participated, 30 to 45,000 in the case of these two vaccines. And what happens, Alan, in these trials is that people are kind of randomized. Basically, by chance, they will get either the mRNA vaccine or a placebo vaccine. They don't know which vaccine they got, and they're followed over time. And they're followed very carefully over time to see what kind of, if they get sick, if they have any adverse events or side effects from the vaccine. And then they're also followed to see if they get SARS coronavirus 2 infection, or particularly in these trials, COVID-19. And basically what we've seen with both the Pfizer and the Moderna vaccine is that there's 95% efficacy. So what that means is that there was a 95% lower risk of getting symptomatic COVID-19 in those who received the vaccine compared to those who got the placebo. And so it was very similar between the two vaccines. But I should emphasize this is after 2 doses of the vaccine. That was the primary endpoints in these trials. And it even takes a week or so after that second dose to have full protection. And the side effect profile was very similar between the two. What we see in terms of side effects with these vaccines, I'll start with the phase 3 trials, are what we call reactogenicity. This is expected inflammation as a consequence of our body's immune system recognizing this foreign protein, basically the spike protein that our cells are making. And so that includes soreness at the site of injection. It includes muscle aches, some joint pain, some headache, some fatigue, some fever. And it was fairly similar between the two vaccines in terms of these side effects. Again, they last from maybe 12 hours after vaccination to 36 hours. Some people, these adverse events are moderate in severity, and maybe they need to take a week off. Maybe they're in bed, maybe they're taking something like Tylenol or Advil to minimize that. But these side effects will go away. In some ways, they're a sign that our body's immune system is working and recognizing the vaccine. Now, after the emergency, so that was what was known really about the side effects at the time the Food and Drug Administration administered or issued the emergency use authorization. And then, but part of that emergency use authorization specified that the pharmaceutical companies need to very carefully follow people who are participants in the trial, as well as other individuals getting these vaccines, for other adverse events, other side effects. And what we've seen is that some people have a more severe allergic reaction following vaccination. We think this is a part of the fatty coat or lipid coat that protects the messenger RNA in the vaccine. And some people have needed, to receive epinephrine or some other, drug to kind of control that allergic reaction. That usually happens very soon after vaccination. Maybe in about 1 in 100,000 people will have this kind of allergic reaction, but that's something that we've learned as more and more people are getting the vaccine, and we'll probably learn more. But it's very important for people to understand that there's very rigorous kind of evaluation and monitoring of side effects as we vaccinate more and more people. So that I'm going to come back to your short answer to your question is, between the Pfizer and the Moderna vaccine, I don't see any difference in terms of what people should be. They're very similar in terms of their side effects and efficacy. They have some differences in terms of the storage. The Pfizer vaccine requires this ultra cold storage that people may have heard about. And the Pfizer vaccine needs to be reconstituted, meaning that it needs to be diluted before it's delivered. So there's some storage and kind of administration differences between the two. But in terms of a vaccine recipient, very similar in terms of their safety and efficacy.
I'm going to encourage folks who joined us to go ahead and post any of the questions they have as we go along. We're going to just be conversing for this hour, and so we hope to get to as many of your questions as possible. One that I had in advance from someone, and it relates to kind of some of the reactions that people might have, and also kind of how a vaccine might react with other drugs we might be taking. And as someone mentioned that some of their students who, for instance, use Flonase had been told that it may make the vaccine less effective. And maybe it's not this specific drug that you're specifically aware about, but are there cases where we might need to modify other drugs that we might be taking so that the vaccine is as effective as possible?
Yeah, so this is an important question, and first I'll say we need to learn more about both the safety and the efficacy of the vaccine in people, particularly people, I'll say broadly, people who have underlying conditions that compromise their immune system, or taking specific drugs that compromise their immune system, or suppress their immune system, I should say. So there's still more to be learned about this, and this is one of the areas of active research going forward, where we will learn more. What I can say is, right now, The only contraindications, meaning the only reason someone should not get one of these vaccines, a COVID-19 vaccine, is if they've had a severe allergic reaction to either a prior dose. So if someone on their first dose had a severe allergic reaction, they should not get a second one. Or if for some reason they know that they're allergic to some component of the vaccine, but that's unlikely for someone to know that. So those are the only kind of strict contraindications to receiving this vaccine. So if someone's taking a drug that may potentially suppress the immune system, it is possible that that the vaccine's efficacy may be reduced by immune suppression. Obviously, that's going to be more likely with more severe immune suppression, whether that's from some underlying disease or some drug that's going to impact the immune system. But that's not a contraindication to getting the vaccine. And also, people whose immune systems are suppressed may be at higher risk for more severe disease. So my recommendation, and I think following the CDC's recommendation, would be those individuals should get the vaccine regardless of what other medications they're taking, perhaps with an understanding that the efficacy may be somewhat reduced if the immune suppressive drugs are stronger, but it's still important for those individuals, and perhaps even more important that those individuals have some protection.
Good. So, say I'm allergic to penicillin, I should not, particularly be worried. And so I think that's so important for us all, all to have clarity on that, because so many, I know certainly in our singing community, people are very attentive to allergic reactions that they may have that affect their singing voice or other aspects of their performing ability. And so teachers are constantly getting questions about that. We're asking ourselves about that as well. So it's a really great, kind of answer to that question that can just really set ourselves, I think, at ease for most of us, that we should have a high level of confidence in taking this vaccine. So when we talk about getting the vaccine, we hear from news reports, but also from our friends. We have those who are resistant to getting the vaccine. How can we as individuals, be advocates, and how can we help explain to our friends who may be resistant to receiving the vaccine to be more receptive to it?
Yeah, this is a really important question, Alan, and it's obviously something that we're all dealing with. Whether those of us in public health, concerned about vaccine hesitancy and some potential mistrust of the vaccine, and just within our circle of family and friends. And so, the first thing I would say is it's critically important to listen. And listen to what the concerns are. Where we don't want to close the discussion, be dismissive. It's just very important to sit and listen and hear what the concerns are, understand what the concerns are, and they vary from individual to individual and from community to community. But without understanding what the concerns are, we obviously cannot address them. So that's very important. Maybe it's an overly simplistic view, but one way I kind of view this situation, and everyone's trying to do what's best for themselves. They're trying to do what's best for their children. When I think about vaccine hesitancy in a broader context, but what often happens is that people underestimate the risk of the disease and overestimate the risk of the vaccine. And this is where information can sometimes be helpful. Factual information will influence some people. I'm not saying it'll influence everyone, but the first thing is to make sure people understand both the and make sure that they're not underestimating the risk of COVID-19 and overestimating the risk of the vaccine. We're in the midst of a terrible, terrible pandemic, and with close to 200,000 cases diagnosed each day, 3,000 to 4,000 deaths each day, hospitals overwhelmed. It could not be, it's hard to imagine in some ways a worse situation. Now, obviously, not everyone gets severely ill. Some people have very mild illness, particularly younger individuals. But everyone's at risk. Even younger individuals can get severe disease. So no one's out of has a zero risk of COVID-19. So that's I think that's one point to emphasize. There is a lot of I'll say lack of trust among some people in some communities around the vaccines. Some people may think that these vaccines were rushed. I can tell people that there was years and years of science behind these vaccines. They were tested very rigorously in the most rigorous manner. We have these large phase 3 trials. Those phase 3 trials don't answer every question. They may not identify every side effect like we're talking about with the severe allergic reactions. But it's as safe as you can get. And so the bottom line is that the risk of COVID-19 far, far outweighs the risk of the vaccine. And that's that is, I think, in short, the message that we need to get across. I know President Biden just yesterday released a very comprehensive national plan, and part of that will be a large public health education campaign to try to correct any misinformation or disinformation around COVID-19 vaccines and vaccines in general. This is coming. This isn't coming on a blank slate. There's a long history of vaccine skepticism and hesitancy in the United States. It's the reason we had large measles outbreaks in the United States in 2019. And so this, but given the immensity of this pandemic, it's really important that we address this problem head on.
Great. I think as of yesterday, if my data is correct, I think the U.S. administered about 18.4 million shots in the and in the last week we've averaged just under maybe 940,000 shots per day. What are the pain points in the process right now, and how do you think they're going to be smoothed over?
Yeah, this is a really important question, and I think we'll see these pain points, as you called them, addressed more directly with this new plan that President Biden presented yesterday. So, Alan, my kind of simple way of thinking about a successful vaccine campaign are what I call the 3 Ds, and it makes it kind of easy to remember: doses, delivery, demand, and data. And so each of these needs to be kind of addressed in order to kind of really have a successful mass vaccination campaign here in the United States. And there's no doubt that this is an enormous undertaking. This is not a simple thing, but it can be done. And so in terms of doses, we need to ensure that we have a sufficient number of doses. We've known that we were not going to have immediately enough doses to vaccinate everyone in the United States who should be vaccinated or wants to be vaccinated. That just takes time to scale up the manufacturing. That'll get easier as more vaccines become available. But for example, there are are ways to do better. In President Biden's plan, they're going to invoke the plan is to invoke the Defense Production Act. That will help mobilize, and it's not just, producing the actual vaccine. It's having sufficient number of needles, syringes, glass vials to store the vaccines, the storage capacity. There's a whole kind of set of supplies and reagents that need to be in place in order to get these to have these vaccines vaccine doses available. So I would say, one, doing everything we can to increase the number of doses. Two, delivery. This is where I think the United States has really run into challenges that we should have been better prepared for. And so there are a number of things that can be done to improve the delivery of vaccines. One is making the eligibility and allocation criteria as simple as possible. I know a lot of thought went into, how we should prioritize groups. And we need something like that. We can't just kind of open it up to everyone. We need a prioritization process, given that we have insufficient number of doses. But I think what we learned was that there were a lot of complexities, operational and logistical complexities to implementing that. By far the easiest criteria are age. It's very easy. People know their age. They can demonstrate their age very easily. Just having simple age criteria is one way to go. Recognizing that we want to protect healthcare workers, essential workers, people with underlying diseases that place them at high risk. Two, expanding the venues where vaccines are administered. That too needs to be done. We've been relying on kind of our traditional ways of getting vaccines into the community, healthcare centers, pharmacies. We need to do much better than that and really expand that. And we're seeing that. We're seeing vaccination sites set up in stadiums, in gymnasiums, maybe even in concert halls. I don't know. But we need to expand the sites, and we need to go into hard to reach communities or disadvantaged communities and be able to administer vaccine there. So there's a whole scope of work to be done about expanding the sites where vaccines administered. Expanding the vaccinator workforce. We cannot rely on kind of our existing healthcare workers and pharmacists, particularly because they're overstretched, taking care of patients with COVID-19, doing the contact tracing, all those kind of things. So we need to expand our kind of workforce in terms of getting vaccines out. So there's a lot we can do in terms of being able to improve our delivery. And just to kind of wrap up the last two Ds, if I can, the demand, we kind of talked about that, addressing the vaccine hesitancy, but also improving the way, just the whole scheduling and appointment process for getting vaccines. I've heard many stories, and in my family as well, just how difficult it's been for people to try to go online and try to schedule an appointment. That whole process needs to be simplified. That process also creates enormous inequities because people in disadvantaged communities may just not have the ability or resources to be able to spend hours online and trying to get an appointment. And then lastly, the data side. We need to be able to track and very clearly monitor our progress in who's being vaccinated, be able to monitor side effects. And so having a standardized data system. Basically, what's happened is that the federal government had kind of left it up to the states to kind of manage all this. And I think that's where we really face challenges. And we really need, in this kind of emergency, this pandemic, we need a strong federal response.
I think one of the things you note about the kind of leaving it up to the states that I think is a particular problem for teachers, particularly those of us who may teach in higher ed or even the independent, studio type teachers, is that teachers have been generally in 1B, in category 1B in most states, but a lot of those limit that currently to K-12 teachers often. They haven't kind of expanded the teacher net to include the higher education people who also, of course, are on the front lines right now, especially if they're having to teach face to face and some of those instances, and fighting to kind of keep their campuses open. And then there's the issue of kind of the independent, community teacher, piano teacher, voice teacher, and some of those kind of teachers who worry or wonder, should I just show up and say I'm a teacher because that is what I do and that's how I make my living.
Yes, so first of all, I'll say, in terms of, opening up schools and creating opportunities for face-to-face teaching, I think vaccines are one tool in our toolbox, obviously, and there are other things that can be done to make that a safe environment. Obviously, as much as possible, some of the standard public health practices, but also, frequent testing and making testing available so that people can be more confident, whether or not they're infected. So there are obviously, as you well know, and the audience well knows, a whole range of tools in our toolbox to try to allow us to open up schools and to facilitate all of this for the teachers. This should how to say, this whole allocation process and prioritization process is problematic. I'm a public health researcher and worker. What I want to see our vaccines do, with a metric that I'm going to be looking for, is if we can begin to reduce hospitalizations and deaths. That, I think, is our number one goal. Once we can get our hospitalizations and deaths down, we can begin focusing on, how do we, maybe other strategies, or, whether or not we're really reducing transmission in the community. And those are correlated, but I want to see our hospitalizations and deaths come down. And so in order to do that, I guess where I'm going with this is, we need to be vaccinating first those individuals who are really at highest risk for hospitalization and death. And perhaps using our vaccines for those populations until we get, and when we get those down, then broadening, who gets vaccinated, but using as much as possible our other public health tools to reduce transmission to other groups.
Yeah. I think there's certainly inevitably going to be there already is the desire, of course, to return to things like face-to-face, voice lessons and rehearsals for choirs. Mm-hmm. And so if we're thinking about, vaccination delivery for one example, and I'd say I've gotten the vaccine today and my second dose, for instance. How long is that till I'm considered kind of fully immune? Yeah. And when I'm considered fully immune, what should we continue to do? And assuming, I'm kind of assuming, yes, we should continue to mask and distance for quite a while, and how long are we estimating right now that would be?
Yeah. These are really important questions, and I know the public health answer here isn't what everyone wants to hear. And there's been an expectation that once we have a vaccine, we're going to be able to go back to normal. And unfortunately, that's not the case. So let's say, Alan, you got your second dose. What the trials show us is that you probably don't have your full protection until about a week or so, after that second dose. But that doesn't. But again, what the trials have told us is that there's 95% efficacy. So not everyone who gets two doses is protected against COVID-19. Now they're going to be very unlikely that someone who got 2 doses is going to have severe disease, be hospitalized and death. They're probably going to have more mild disease, but it's not I guess the first point I want to make is that these vaccines are not 100% effective. The second point is that we still do not know, and this is an active area of research going forward, we still do not know whether people who've gotten their 2 doses, whether or not they can get what we call asymptomatic infection, be infected but not have symptoms, and whether they can transmit. The studies that were done looked at disease. Do these vaccines prevent people from getting disease, mild, moderate, severe? Not whether do these vaccines prevent transmission. It's likely that they're going to markedly reduce transmission. That's what I would expect. But whether they completely transmit infection and transmission is probably unlikely. That's a high bar for a vaccine. So it will be possible. Again, we don't have all the evidence yet, but that someone who's gotten 2 doses of the vaccine might be able to, get a very, very mild infection with SARS coronavirus 2 and transmit that virus. So that's the reason, those are the reasons why public health recommendations are that even individuals who've received 2 vaccine doses continue to practice the same very important public health measures. Now, what I see, at the other end of this, when we start to come out of this, so first, as I mentioned before, we want to see the hospitalizations and deaths come down. What I see is kind of a more phased return to normality, if you will. Allowing, smaller groups, maybe it's smaller classrooms, once we have a large proportion of the population vaccinated, and then maybe going to larger groups of people coming together. Maybe kind of at the end of that, we're talking about, opening up sports stadiums where we have, tens of thousands of people together. Where do concert halls kind of fall in that? The concert going population is often an older going population. I hope that's changing, Alan, but it is, at higher risk of disease, but also maybe at higher risk of or more likelihood of getting vaccinated or early on. So in concert halls, you've got this trade-off of, the risk of the population and bringing people together. And obviously, as you all know in this audience, singing is a way of, these respiratory droplets and airborne droplets. So it is a higher risk activity. And so that's maybe, unfortunately, going to be kind of later in this more phased approach where say you may be able to get choirs to come together en masse. But where I see us going is we get the hospitalizations, deaths down, we start getting the case numbers down, and when where we want to be, Alan, is where we've talked about case identification, testing, identifying cases, contact tracing, isolation, and quarantine, that whole package that we heard about. We weren't able to implement that efficiently because the caseload was so high. That's going to be our big tool at the back end of this, where we do extensive testing, identify infected individuals early, have them isolate, be able to do effective contact tracing, and that's how we're going to manage this at the back end once we get the case numbers down.
Do you think that we have some of these rapid tests, at home even, that are in development and production? Do you feel like those are going to be very effective and a big tool for what you're talking about?
I think so. I think testing, again, at the back end, we can't do that all of that right now because the case numbers are just too high. At 200,000 new cases a day in the United States, it just overwhelms the public health system. Although that needs to be expanded. But I do see these kind of rapid at-home tests playing a very important role. Again, our strategy will be at the kind of our end game, if you will be because this virus isn't going to go away, and but what we need to be able to do is identify infected individuals very early, and institute those basic public health measures of isolation, contact tracing, and quarantine, to be able to control this pandemic at the back end. And I do think that home testing will be a big part of that.
Mm-hmm. A couple of questions from our audience. One person mentions having heard conflicting views about the drinking of alcohol, both immediately before and after receiving vaccines. Your thoughts on that?
Yeah, I've been asked this question a number of times. It's interesting, and I think it came out of, now I have to remember, I think it came out of a recommendation in the UK, that people avoid drinking around the vaccine. Here's my kind of honest answer. Excessive alcohol drinking is bad for multiple reasons. Casual, moderate, mild to moderate alcohol consumption will not adversely affect either the safety or the efficacy of the vaccine. So it's an interesting kind of issue that has risen in the public, but there's no reason to think that casual or mild moderate alcohol consumption will be harmful.
Now we've been hearing about some of the variant mutations of things of the virus, and if it's proven that the vaccines are not as effective against some of these variant mutations, will likely second doses be tweaked, or might we be in a situation where those who are vaccinated early will have to have a later some kind of booster or second vaccine?
Yeah, this too is a really important question. There's still a lot to be learned about these variants, and so just a few reflections on this. Oops. Is that me? Sorry. My apologies. A few reflections on these variants. So first of all, and I think most of the audience knows, viruses mutate, and the more they transmit, the more infections we have, the more opportunities there are for viruses to mutate. And so, our biggest weapon, I'll say, against seeing more and more of these variants is to try to reduce transmission as much as we can through the public health measures. We've provided this virus enormous opportunities to mutate. What we've been seeing, and obviously in South Africa, there's the South Africa variant, the Brazil variant, the UK variant. These are kind of variants of the virus that have accumulated a number of different mutations from the original virus. And we've seen mutations in this virus all along. There was a mutation very early on that became dominant around the world. That's just how viruses evolve. It's natural selection and evolution in action. What the concern is that there have been, the first concern has been about the transmissibility of these viruses. And that was raised because these variants seem to become the predominant genetic variant in certain populations, obviously first in the UK and then in South Africa. And that suggests that these may be more transmissible. And so there's still a lot of work trying to figure this out. And what we're particularly interested in are mutations in that spike protein that we were talking about earlier. And one hypothesis here, and there's some evidence to support this, is that maybe these variants bind more tightly to that cellular receptor, allow the virus to get better at entering our cells. There's some suggestive evidence that maybe they replicate more in our cells so that we have a higher viral load and thus are more kind of infectious. But obviously, then the question becomes, so that's around the transmissibility of these variants. There's obviously interest in whether they cause more severe disease. There's no evidence that they cause more severe disease, but simply by being more transmissible, they may cause more infections, thus cause more hospitalizations, and thus cause more deaths. In terms of the vaccine, the interest and focus has been on mutations in this spike protein, and so one could imagine that if that spike protein changes in its configuration, in its form enough, that the antibodies that were produced against kind of an earlier version, if you will, of that spike protein may not bind as well may not block the spike protein as well. I don't think it's going to go to zero. These aren't going to be complete kind of escape mutants where the vaccine has no protective efficacy at all. The question is whether there's some reduction in the efficacy. We don't have any evidence of that. There have been investigators who've looked at one or two of these mutations kind of in isolation, don't see any evidence that there's reduced kind of neutralization of the virus. But this is going to be an active area of research going forward. Now, let's just say the worst case scenario, let's say one of these variants evolves so that the vaccine is not protective or has markedly reduced protective efficacy. One of the nice things about this messenger RNA technology is that it's relatively straightforward to create a new vaccine. You just kind of put in the genetic recipe for the new variant. That takes, I've heard, on the order of, 4 to 6 weeks, the vaccine manufacturers could do that. But then we have the whole regulatory side. How long would it take for such a new vaccine, if you will, to be kind of go through the approval process? I don't think it would have to go through the whole large phase 3 trial that we saw before. There are ways to expedite it if we have what we call correlates of protection. If we know certain antibody levels are protective, we could be looking for that with these new vaccines. I don't think we're going to get there, where we really need a new vaccine soon. But obviously, this is an area of intense research, and we're just going to have to see how this plays out.
What about those who have already, contracted COVID, survived COVID? What about, their process? Should they immediately get vaccinated as soon as possible?
Yes, no, this too is a commonly asked question. And the current recommendations are that individuals who previously had COVID-19 should still be vaccinated. And it would be, if whatever group, in that, 1A, 1B, or, as we move along the prioritization process, if they fall within that, they should be vaccinated. Now, the reason behind this is that, there's no doubt that people who've had COVID-19 will obviously have seen the virus and have some immune response to it. But that immune response to natural infection can be quite variable. And particularly for individuals who've had milder disease, they may have kind of a shorter-lived immune response. We're still kind of learning about the longevity or durability of these immune responses. But the general recommendation is that because of the uncertainty, I'll say, or variation in the immune response to natural infection, and because we know very well what the protective efficacy is of the vaccine, that those individuals get vaccinated.
Great. If we get the COVID vaccine, someone was asking, how long should we wait to get other types of shots, like maybe a shingles shot or, some of the other common shots that we might get?
Right. No, that too is a very important question. That hasn't been intensively kind of studied yet, but the general recommendations are to avoid other immunizations 2 weeks before and 2 weeks after a COVID-19 vaccine. We don't anticipate any kind of adverse interaction between the two vaccines, but there could be, and that would be a reason to avoid. The shingles vaccine, the Shingrix vaccine, also has a fairly high degree of what referred to earlier as reactogenicity, this inflammation, this fever and soreness and muscle aches. And so you don't want to kind of have two vaccines kind of hitting you at the same time. You'll get over it, but so in general, the advice would be to avoid other vaccines 2 weeks before and 2 weeks after.
Right. Well, Dr. Fauci has said within the last week that we could see Broadway reopening and singing in churches again, maybe mid-fall. What are your thoughts about this? And what are the data points that, the common person should be kind of monitoring? What should we be monitoring ourselves to kind of know that the progress is happening and we're feeling, better in our communities about these kind of things?
Right. No, this is really important, and I'm not one to contradict Dr. Fauci, but and I think that's an optimistic view. It's a hopeful view. It's not a completely unrealistic view that we'll, be back to a much more normal life in the fall, and I'm hopeful for that too. As I said earlier, I see as kind of more of a phased return to normality. Maybe, and one way of thinking about that is, as I said, are these kind of permitting kind of smaller groups, maybe that's indoor dining, as a smaller group, and then kind of, larger and larger gatherings being permissible or reasonable. The metrics. Coming back to what I said earlier, I first want to see the hospitalizations and deaths go down. That's our first main goal with vaccination. And then I would say, when we're going to really start to be able to return to our normal life is when we're in that situation where we can identify cases early and do that isolation, contact tracing, quarantine. When we're in that phase, that's when I think we're going to really be able to return as closely as possible to our pre-pandemic life. That's how we're going to manage this virus, in my view, in the near future, once we get the case numbers down. So first hospitalizations and deaths, then getting the case numbers down, then being able to manage that with testing and contact tracing. And that's when we're going to be able to really begin to return to our pre-pandemic lives as much as possible.
And just for comparison to those of us who are listening to this, would a good example of that be some of the kind of strict contact tracing and testing like that happened in New Zealand, for instance, and some of the other places where they really jumped on and have been keeping track of things, and as soon as they saw something, an anomaly happening, they were jumping on it and upping the tracing and all of that, so that
exactly
could kind of
exactly. And we tried to do that, Alan, obviously in the United States, but we were too far behind. That's a strategy that works kind of in the beginning of an outbreak and at the end of a pandemic. But once that caseload, that we just got far behind the curve there, and had too many cases for our public health system to be able to handle that. So the case number needs to go down, but we also need to expand our capacity to do the testing, as we were talking about earlier, to do the testing and the contact tracing. That's how we're going to get out of this.
Let me just give a scenario. Say we have a church choir, and say everybody gets vaccinated in that choir. So we think, okay, well, let's rehearse.
Yep.
Let's start rehearsing. Should we continue to rehearse masks? Should we continue to keep our limits on maybe 30 minutes, no longer than that? Should we keep going with kind of the same restrictions we've recommended, which are things like that, and
Yeah.
rehearsing outdoors when possible, changing locations, after the 30 minutes and things like that.
Yeah, so my own personal opinion on this, Alan, would be the answer would be yes. So even if everyone's vaccinated, had their 2 doses, I think it would be at least in the first phase, I'll call it, in the early phase of kind of coming out of this pandemic, to continue those kind of basic public health practices. As community, when you really start seeing community transmission go down, meaning you get down to these really kind of low numbers of new cases identified, they're kind of sporadic, we've got this contact tracing system in place, then I think we can begin to relax some of that. But I think, again, I would think of it in terms of phases, and I would, that first phase of kind of coming together and doing in-person rehearsals for a choir, I would start with those basic public health measures and continue those. Yeah.
So I think, one of the messages that I think that is a really important message that you bring to us today, especially, is that just because we individually have been vaccinated, we still don't know, whether we might be able to carry the virus and spread the virus unknowingly to others. And of course, once we get more data, we may know some more about that. But it really is so incumbent upon us to maintain, as hard as it is, to kind of fight the fatigue that we have, and keep our spirits up, and keep the spirits of those who love performing and love singing, up in the ways that we've been able to do that, and continue our creative ways of making music during this time, and until we can kind of get the green light, and we'll be certainly calling on people like you and others who are certainly sensitive and aware of the kind of issues that we particularly face in the singing community,
Yes.
to kind of check back in and give us some green lights, and so that, because I do think one of the issues that we all face is, what data do we follow, and whose data do we follow, and what, we see this in one place and that in another place, and we don't always know, all the numbers aren't being interpreted necessarily well for the common person. And then there are those of us in the performing arts who, of course, think we're special and think that, we have unique needs and unique situations during this pandemic that we're hyper concerned about, I think.
Yeah. Well, I completely agree with what you said, Alan. And, obviously, what you all do is so important to us as a society. And, but by the nature of your work, and particularly singing, it's higher risk. You're bringing people together. You're singing that creates an opportunity for virus transmission. But we will get through this, and we'll get to the other side. I have no doubt. And we need musicians and singers to help heal our soul during these moments as well.
Definitely. And I know we're about out of time, but I said I might ask you this. You have a good Heidi story for us?
Well, she may be listening, so I have to be careful.
Well, I'm sure she is.
But I'll just a very recent one. She's married to Kurt Erickson, who's a musician, pianist, composer, and they could have been. They're together in their bubble, and I think they just recently realized that they could be creating music together as husband and wife in their home, and I think they can continue to do that going forward, even under these difficult times.
I think as we go forward, it's just so important for us to kind of keep track of some of this, and really. I know in the NATS community, at least, we continue to kind of plan for a variety of scenarios for events that NATS sponsors, and hoping for the best, but also keeping as close a monitor on what kinds of efficacy is, how the efficacy of vaccinations and things is progressing. And so, we keep doing that. And I know everyone around in the performing arts community is doing a lot of that these days, and trying to kind of plan for all the scenarios that might come at them, and that's another, I think, important factor in all of us and planning performances and planning all kinds of events, is to kind of have these multiple solutions depending on what the data tells us. And it can, I think, I don't know what you think, but I think it will, like the virus has impacted different communities in different ways, it seems like we're going to see, some places being able to open up before others.
Yeah. Yes, and I'm also hopeful that I think we will now have a strong, federal response, and the information flow will be better. So I'm very optimistic. There's no doubt that the next few months are going to be hard, particularly hard in some communities. But I think we will get through this. And I'm hopeful that I hope that Dr. Fauci is right, that by the mid-fall, choirs will be producing their beautiful music.
Yeah. His lips to God's ears, I think, is what we certainly what I thought when I heard him say that. Just we do remain hopeful, and we're so grateful for the work that you do. We're so appreciative. I know you're a busy person, of taking the time today to kind of explain so completely and so well to us some of the not only the difficulties we face in this effort, but also kind of some of the bright spots of what is happening now, and some of the amazing progress science has given us in recent days, and how we can move forward, not only as a singing community, but as a country, and within the world, as we seek to fight this pandemic. So thank you so much for joining us today. Thank you to those who submitted questions. I think we got to almost all of them. And we hope that you will continue to share the recording of this talk today as with your friends. It will be immediately available on our YouTube channel. And we've had several questions about kind of futures issues, and we are planning a webinar where we will begin talking about futures issues. What does the fall look like for us in higher education and in our singing community? So watch out for our panel that we'll have of experts that will kind of talk with us about the future and how we think facing the future is important, and also planning for the future, and what we think that what are some lessons we've learned during this pandemic that might be a positive for our community going forward. Mm-hmm. So I look forward to that talk. Again, we thank you, Dr. Moss, for joining us today. We're so grateful for your work, and good luck in all your future work.
Thank you very much. It was my pleasure.